Hi everyone, this is Chase Coleman with UMA, and this video is the first video of our game theory series. So before we talk about game theory, it's important to understand what is a game. So John von Neumann, who is a famous economist, defined a game as four things. First, a collection of players. So we need to know who's playing the game. We might call these people player 1, player 2, etc. We might also sometimes give them names. We might call player 1 Alice or player 2 Bob. Next, we need a set of actions that can be taken by each player. For example, Alice, or player 1, might be able to choose to go left or right, while player 2, Bob, may be able to choose up or down. Next, we need a payoff function, which is just some function that maps the actions taken by each player into that player's utility. So Alice's utility, when Alice goes left and Bob goes up, might be equal to 1. But Alice's utility, when she goes left, but Bob goes down, might be -1. So we just need to be able to specify what each person's payoffs are based on the entire set of actions taken. And finally, we need a timing protocol, which is just going to be some protocol that specify who gets to move or who gets to choose what action and when. We find it helpful to start by talking about an example. And in this case, we'll use a canonical example known as the prisoner's dilemma. In the prisoner's dilemma, there are two criminals who have been caught committing a crime. The police don't have enough evidence to arrest the two criminals for the more serious of the crimes they had committed, but they do have enough evidence to arrest them for a less serious crime. Once the criminals have been arrested and taken back to the police station, the two criminals are split up and they're taken to separate rooms and offered the following deal. If you rat out your partner, then you get to walk away free and your partner is going to receive the maximum sentence. If you rat your partner out and your partner rats you out, well, we didn't really need you to rat the other person out, so we'll give you a slightly reduced sentence, but you're not going to be able to walk. And finally, if both criminals stay silent, then they can only be arrested and held for the less serious of the crimes. So if we try and put this into the four components of game theory that John von Neumann gave us, we have two players, criminal 1 and criminal 2. The actions that criminal 1 is allowed to take are rat and stay silent. So they can he or she can either rat out their partner or they can stay silent. Player 2 has the same set of actions. The payoffs were specified here, where if you rat out while your partner stays silent, you get to walk away. If you rat out and your partner rats out, you both are convicted of the more serious crime but receive slightly reduced sentences. And if you're both silent, then you can only be arrested and held on the less serious crime. And we'll put numbers to these as an illustration in the next slide. Finally, we need a timing protocol. Because the prisoners have been separated and taken to separate rooms, we view this as the prisoners are taking action simultaneously because they don't know what their partner is going to do. We're going to represent this game using the following payoff matrix. And how does this matrix work? This matrix says if criminal 1 rats and criminal 2 rat, so if they rat each other out, criminal 1 receives a payoff of -1 and criminal 2 receives a payoff of -1. If criminal 1 rats while their partner stays silent, criminal 1 is going to receive 4. They get to walk away, while criminal 2 is going to receive -2, which is the maximum sentence. If player 1 stays silent while criminal 2 rats them out, player 1 is going to receive the maximum sentence, -2, while player 2 gets to walk with utility 4. And if both criminals are silent, then they each receive payoff 3. So the important thing is the first number corresponds to the payoff for player 1, and the second number corresponds to the payoff for player 2. Now, that's all we have for today. We formally defined what a game consists of, which is players, actions, payoffs, and timing. And then we discussed the canonical example of the prisoner's dilemma. And that wraps everything up, and we'll see you next time.